Good day, grade 12 learners. Welcome to today's technical mathematics lesson. My name is Moses Maudu. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. So today's lesson will be on analytical geometry, and the part that we're going to be looking at is the circles. That is a grade 12 topic. The lesson objectives: by the end of this lesson, after we're done with this lesson, you must be able to do the following. You must be able to determine the equation of the circle in the form x squared plus y squared equals to r squared, with the radius r and the center at the origin 0 and 0. The equation of the tangent to a circle at a given point, we must be able to determine that at a given point. We must be able to determine the points of intersection of a circle and a straight line. We must be able to plot the graph of an ellipse in that form: x squared over y squared plus y squared over a squared, plus y squared over b squared is equals to 1. So those are the objectives of this lesson today. What is that circle that we're going to be talking to? So it is a set of points that are equidistant from the given point at the center. It is round. It's a round shape where every point on the edge is equidistant from the center point. So what does that mean? It means that I've got a center, I've got a point here at the circumference of the circle, and if those points are joined together and these lines are equal, which are called radii, equidistant, in other words, they are equal to each other in length. Therefore, if I join those points from there, then I get a circle. So all those ones are radii, so we've got all of them, they are the same length, so that is a circle. Right. Now, how do I find that equation of that particular circle? Here's an easy example that we can do. Look at this. So if I've got a Cartesian plane with those blocks there, I see those blocks there, the one block there, it's equals to 1 unit. So I'll have 1, 2, 3. So up to here, I'll have 3 blocks, which give me 3 units. From here up there, I'll have 1, 2, 3, 4 blocks. That gives me 4 units. And that coordinate will be the x value and the y value. And those ones will give me the coordinates of that point. For me to get that, remember the line that is from the center of the circle to the circumference, it's called a radius. So that 5 here is a radius. Right. So for me to get the equation of the circle, I'll use what I call the theorem of Pythagoras that we have done in grade 9. Now the theorem of Pythagoras states that if I've got these two values, the x value and the y value, the square of this side of the x and the square of this side on the y will give me the square of the longest side, which is the hypotenuse in that circle, which is the radius. So which means if I take the square of x and I take the square of y, that will be equals to the square of r. So I'll have x squared plus y squared equals to r squared. I don't know what is r squared, I just know what is r. So in this case, I need to find the equation of the circle. So I'll rather take x squared plus y squared, and I can then get the answer there, which is 9 plus 16, and that will be 25. Now look at this, let's see this. If I take that r and square it, I still get 25. So can you see that the x squared plus y squared will be the same as r squared? So my 25 will be my r squared. So if I'm given the radius, I can be able to get the equation of the circle. If I'm given a point, I can be able to get the equation of the circle. In this case, I should have done x squared plus y squared will be equals to r squared, and the r is 5. So there will be x squared plus y squared equals to 25, and that will be the equation of the circle. So I can use this point to get the equation of the circle to get the value of r, or I can use that r to get the equation of the circle. So the questions will be in this form. It's either you'll be given the r only and they say find the equation of the circle, or you can be given the point x and y and they say find the equation of the circle. So those two. Right? Now, in the next one, find the equation of the circle. In this case here, I can then see that in this case, I'm given that one block will represent 1 unit. So which means from here to there, it's 1 unit, 2 units, 3 units, 4 units. So in other words, that line here from here will be 4 units. So if I check this line here, it is from the center of the circle to the circle. So it's a radius in this case. So I'll have a radius here. Okay. So in the previous one, that 3 was not the radius because it did not touch the circle. In this case here, I've got a radius. How do I get the equation of the circle if I've got a radius? So I'll go x squared plus y squared is equals to r squared. That is the equation of the circle. As I said, it is from the theorem of Pythagoras. So then I'll have my x, I'll write it as x squared, y squared. The radius is 4, so it must be squared, and the equation is as simple as that. I'll have that one at 16. So that is my equation of the circle. And that's exactly what we'll be doing throughout. So if I need the equation of the circle, this is what I'll do. So I'll have x squared plus y squared equals to r squared, and then from the r squared I can be able to get the equation of the circle. Remember, this is r squared, it is not r, so we must treat it as such. It must be r squared, not r. Mistakes that we always do is when we arrive here for the value of r, then we put a 4. The 4 is the radius, but then we need a radius squared. Remember, that is our hypotenuse if we have a right angle triangle. Right, let's look at now activity number 2. Now we know how to get the equation of the circle, but now how do we then get the radius if the equation of the circle is given? In this case, I'm given x squared plus y squared equals to 25. Remember, there are 3 ways of writing a circle. It's either of writing a circle and a semicircle. So we've got a circle, which is a full circle, which is x squared plus y squared, it's r squared. The other one will be y. In this case, it must be y. It's equals to plus minus the square root of that, 17 minus x squared. Okay, so the other way of writing it will be y is equals to minus the square root of 17 minus x squared, or y equals to positive the square root of 17 minus x squared. So we've got 3 ways of doing that. So if you look at, I'm going to put it here. So if I've got x squared plus y squared equals to r squared, and that will be a full circle, right? So if I've got y equals to the square root of r squared minus x squared, that circle here will be the circle which is above the x-axis. If I've got y equals to negative the square root of r squared minus x squared, then I'll have a circle which is below the x-axis. Right, so this you must know. Now in this case here we are having x squared plus y squared equals to r squared. The r squared is 25, but now I need a radius. So what will be my radius? R squared is 25. Remember, the R will always be positive. So my R in this case will be equals to square root of 25, which is 5. In this one here, now I can see I have got the Y, I've got the X. So I need the R. So the R should be this one, as in there. So the R squared will be 17. So my R squared is square root of 17. So the R squared is going to be 17 because that's your R squared. Then, which means that my R will be equal to the square root of 17. Not plus minus, but positive only. If I look at the last one here, for me to get the equation like this, I need to first divide here. So I must first divide this by 2, divide it by 2, divide this by 2. So that then I can get the equation x squared in that form plus y squared equals 2r squared. In this case, the r squared will be 14. So which means that my r squared is 14. But my R value will be the square root of 14. Please, let's leave it in set form, okay? So those are the two answers that I'm going to get. So the three answers that I'm going to get for those three things. So if you're asked what is the radius of the circle, I must take the square root of that one. If I'm asked what is the equation of the circle, I must use that R and square it, so that then I can get the proper equation of the circle. Mistake that we always do is, if I'm given that 25, then the R is 5, then I tend to say x squared plus y squared equals to 5, and that is incorrect. So the square root of 25 is 5, and that 5 is the radius. The 25 is the R squared that must go into the formula. All right. Now looking at activity number 2, how do I find the equation of the circle if I'm given that? Now, in this case here, there is a line that is passing at that point J here, which is 12 and 9. So 12 and 9 is a point on the circle. So once the point is on the circle, which means they can substitute this point on the equation of the circle. JK is a tangent to that, so we'll talk to the tangent later on again. So JK is a tangent to that, so determine the equation of the circle passing through J. So which means, in this case, first I must write down the equation of the circle. So the equation of the circle is x squared plus y squared equals to r squared. Once I've done that, I know that my coordinates must be written as x and y. So what is missing here? It is the radius. So I need the radius. I need the r. So if you look at this diagram, I can put it like that. I'll have a 12 here and a 9 there. So I can use the theorem of Pythagoras to get the r. But remember, I need r squared. So which means that I must square that value. So the x will be 12, my y value will be 9 equals to r squared. So I need r squared. For me to complete this equation, I need r squared. So I'll have 144 plus 81 equals to r squared. That's what I would need. So 144 plus 81 gives me 225 equals to r squared. So my r value will be equals to, then I can say plus minus the square root of 225, but always remember r should be positive. So I can then get the square root of 225, and the square root of 225 will be 15 according to my calculator. Then I'll have r. But remember, I do not want r here. I need r squared. So it is not necessary for me to have that unless I'm asked to get the radius of that circle. So which means then, therefore, my equation of the line will be x squared plus y squared equals to 225. Remember, my r squared is 225. So that will be the equation of that line, of that circle, so that passes through points J, 12, and 9. So please, that R should not come in there. If it comes in there, then you must square it. So in other words, you must say x squared plus y squared equals to R15 squared, which brings you back to 225. So once you get R squared here, please just go and replace it on the equation. First, we must always write down that equation so that then we know that we're substituting into that equation, and then we must substitute correctly. The x value is the first term there, first value there is the x, the second value there is the y, so we must substitute correctly. Right. Here's a question, no sketch, nothing. What are you given? You're given we know we are working with a circle. The center is at the origin, which means that there will be 0 and 0. And now we're given the radius of 7 units. So the radius is given now, it's 7 units. So what do I need now? I need to find the equation of the circle. So how do I get the equation of the circle? Remember, it's as simple as getting x squared plus y squared equals to r squared. What is now given? What is given now, it is the radius. So if the radius is given, no problem. Just substitute the radius. The x and the y, it's not a problem here because it's part of the equation. What is not part of the equation is that r squared, which we need to get. So now every time I need the equation of the circle, I must look for r, and then I must square it. So I'll have x squared, that's a simple one, plus y squared equals to, the r is the radius, which is 7 units, so I must put 7 here, squared. That gives me x squared plus y squared, it's equals to 49. And I'm done getting the equation. So it must not be a 7, it must be a 49. Now if you want to be smart, the other way of writing it will be, if you want to be smart, so it will be y, it's equals to, because it's the full circle, it must be plus or minus the square root of 49 minus x squared. Now maybe you are asking, why are you writing it as y equals to plus? Why do we write it as y equals to plus minus the square root of 49? This is how it comes about. So if I've got x squared plus y squared equals to 49, then if I take x squared to my right hand side, so I'll have y squared equals to 49 minus x squared. You see that is coming up now. Now I want to write my graph as y is equals to without a square. So if I take the square root this side and take the square root that side, I must put plus minus on the other side. Then the y value will be plus or minus the square root of 49 minus x squared. You see, that's how we write that equation. So that equation can be written in this form, can be written as y is equals to plus or minus. Remember, if it's a plus, it's circle above the x-axis. If it's a minus, it's a circle below the x-axis. So we need to write it properly. So that should be, if you're writing it like this, you'll get a full marks. When you write it like this, you'll get full marks. Okay. The easier way to write it will be like that, so that you don't make a mistake. Because most of the time we find that you make a mistake and that sign there is positive, and that gives you a wrong equation. All right. Now looking at equation activity number 4, points on the circle. This is another question that is asked in the exam. I mean, this section is so easy. It's very easy. In this case, yeah, the circle is at the center. I mean, the origin is it's the point there, 0, 0. So here's my circle. So obviously, if my radius squared is 25, my radius will be 5. So it will be 5 minus 5, 5 minus 5, and 5. So here I can just quickly draw my circle. Looks like a circle. Okay. Now they're asking me if point 2 and 1. So if this is 5 and there is maybe 1, 2 is there and 1 is there, they're asking if that point it lies on the circle. But I cannot just draw that and then from there indicate it on the sketch. I must work it out. So now 2 and 1, how do I work that one out? For instance, if I take x squared plus y squared, this must give me 25. So let's check this. X it's 2, y is 1. So if I work this one out, I'll get 4 plus 1, and that will give me 5. And 5, it's not equals to 25. Therefore, point 2 and 1 does not lie. Does not lie on the circle. So where does it lie? If the number is smaller, it lies inside the circle. If that number was bigger than 25, it will lie outside the circle. So these are questions that they ask in the exam. So in this case, I've just drawn a picture of that to show you that that point will lie inside the circle, because the value 5 is way less than 25. If I got 41, for instance, then that point will lie outside the circle. Now let's check B and see if B makes sense. Now with B, if I say minus 3 squared plus minus 4 squared, the answer that I'm going to get is 9 plus 16, and 9 plus 16 is 25. If this answer here is the same as the radius squared, remember if I square this, I get r squared, right? So if this number is exactly the same as the one that was given, therefore what do we say? That point here will lie, the point minus 3 and minus 4 will lie on the circle. So the point will lie on the circle. So meaning that that point will be minus 3 will be somewhere there, and then minus 4 will be somewhere there. So that point will lie exactly on the circle, because the answer that we're getting here, it's 25, and it's the same answer as we were given. So these are critical questions that you must know. So if, for instance, the point was given, and then from there we have bigger than 25, as I said, that point will lie outside the circle. If the r squared gives us the same numbers, that one is given, it lies on the circle. If the point is smaller than 25, the value is smaller than 25, it lies inside the circle. Three things: bigger, outside, equals to, on the circle, and less than the radius squared, inside the circle. Please, we must know that. All right. Now the next activity 5, it says the equation of the circle is given by x squared plus y squared equals to 9. Calculate the radius of the circle. Remember, the radius of the circle is not 9, but what you do is you say radius squared equals to 9 my radius will be the square root of 9, and the square root of 9 is 3. Remember, with r, it's always a positive value. Now they say draw an accurate graph of a circle. So in this case, if the radius is 3, it means that from my center up, it's going to be a 3. On my right, it must be 3. It's a radius. Remember, this line and that line are of the same distance, so they're equidistant. So the other side will be -3, the other one will be -3. Remember, we're talking radius, we are not talking the points there. So in other words, that is 3, so we have a 3, and then from there I can have a circle that goes through 3, it goes through -3, it goes through 3, and we'll have a circle. Sorry, a circle that goes there. Right? So obviously, when you want to draw this, you put your compass there, and then from there you are able to can draw a better circle than mine. Mine, you know, it's a freehand circle, and you have to draw it by using your instruments. Most of you, all of you are doing EGD, and it's very easy for you to can draw a better circle than mine, because I'm using a freehand. Okay, right. Now, when we talk about the equation of the tangent, what is a tangent? So first of all, we must first look at this tangent to a circle. So what is that tangent to a circle? Because a tangent can mean a lot of things, but in this case, the tangent to a circle. So if I've got a circle, and I've got that line that passes through one point, it touches only one point on the circle. That line is called a tangent. And how do we call it? A tangent of a circle. Because now I'm talking about a circle. But we can have a tangent to graph to a parabola. We can have a tangent to have a hyperbola. So here we're talking about the tangent to a circle. Now a tangent is a line that touches a circle at only one point. So if you see a line touching the circle at 2 points, that cannot be a tangent. The name for that line that touches at 2 points, it will be called a secant. So a secant is a line that touches the circle at 2 points. So if I've got a line that touches, for instance, there and there, a straight line that touches there and there, so we'll call this one a secant. Okay. In this case, I can be given the points there and there. I can be able to get, or I can be given the equation of the graph, of this straight line graph. Then I can be able to get this point and that point, if I'm also given the equation of the circle. So in this case here, the tangent is at this point, and we know that from the center of the circle to the point of contact, the angle that is formed there will be 90 degrees. In other words, the tangent is perpendicular to the radius. Right. So a tangent is perpendicular to the radius of the circle at a point of contact. It's very important. We can't draw a line here and then from there we say it's 90 degrees. That is incorrect. So we're saying from the center to the point of contact, where remember the tangent is touching the circle at one point, but at the point of contact, that circle, that line or a diameter will be perpendicular to that. In grade 11 you have done the geometry. In geometry you have the theorem that says tan perpendicular to radius, or radius perpendicular to the tangent. So that is where it's going to work. Another thing that we need to know again here is the product of the gradients on the radius. These are very, very important notes before we can do the equation of the tangent. The product of the gradients of the radius and the circle is -1. Reason? The gradient of the radius times the gradient of the tangent will give me -1. Because of perpendicular lines, when you're doing your straight lines, perpendicular and parallel lines, you know that if I've got the gradient of the radius, the gradient of one line times the gradient of the other line, if they give me -1, it means that the lines are perpendicular. The next point, to determine the equation of a tangent, what do we need? We need the gradient. If I've got the gradient and one point on the tangent, then I am good to go to get the equation of the straight line. Remember, the tangent is a straight line, which means the equation of the tangent will be y minus y1 equals to m into x minus 1, x1. So if I've got a point and if I've got a gradient and I've got a point which is x and y, I'm able to get the equation of the circle. Y equals to mx plus c will be the same thing. So if I've got a gradient, I can then substitute the value of x and y, and then from there I can get the value of c, which will be my y-intercept. The easy way of doing it will be using that method because it gives you an equation rather than getting the value of c and then forgetting to then write it in the form y equals to. And that is what I am explaining now. The standard equation of the line is y equals to mx plus c, or we can use that. As I said, this one is the easier one because it takes you straight to the equation of y equals to. The point of contact we have already talked about. That's where the tangent touches the circle. So it touches the circle at one point, and that point is called the point of contact. Here is the point of contact as indicated, as I'm indicating there. So once you understand this, the equation of the circle will be very easy. So if you look at the next activity, it's all about just practicing how to write down the gradient of the line perpendicular to the gradients that have been given. So now in this case, the gradient is given as -3. These are gradients. So the gradient is given as -3. We need the gradient of the line perpendicular to that. So if this is the gradient at -3, what will be the gradient of the perpendicular? So the gradient of the perpendicular, remember we said, if I take the gradient of a line times the gradient of its perpendicular line, the answer must give me -1. So the easier way to do it will be, if I've got this one as -3, so I know it's -3 over 1. So I just tip and turn. So in other words, take the denominator, make it the numerator, numerator the denominator. So I just swap these values, that one up, that one down, and I change that sign. So the gradient of the perpendicular will be 1 over 3. It will be a positive value. Why positive value? Because this one was negative, therefore the other one will be a positive. Same applies to this one. The gradient of that is 5 over 3. Therefore the gradient of the perpendicular will be, swap it, 3 over 5, and just change the sign. So the sign was positive here, there it becomes negative. So that then if I take these two values and multiply them, if I take 5 over 3 and multiply it to -3 over 5, the answer should give me -1 because 3 cancels out, divides, this one divides into that. So we've got answer -1. So the two gradients, when they multiply together, we get -1. To get the tangent of 60, remember, the gradient is its tangent of an angle. So why is it a tangent? This is because if I've got a Cartesian plane and I've got this, and I've got 3, I've got 4, I've got a 5, for instance. I'm using this simple number, 3, 4, 5. Now, if I've got an angle here, for me to get the tangent of this angle, I'll use 4/3. So I'm using the y/x. And in trigonometry, if you remember, y/x is tangent of an angle. So the tangent of an angle will be opposite over hypotenuse. So in this case, y/x is tan theta. But how do I connect it to the gradient? So the gradient, remember, is the change in y over the change in x. So which means it's y2 minus y1 over x2 minus x1. So you still use the y value on top and the x value at the bottom, and that is why the tangent is associated to the gradient. Right. So tan 60 is the gradient, so which means that the tan of 60 is going to be square root of 3/1, which means that the gradient of the perpendicular of that line, so it means that that angle there, if it's 60 degrees, so the gradient of the perpendicular will be equals to -1/√3. Easy, straightforward. So the gradient of that line is tan 60, and these are questions that can be asked in an exam to say, if I've got here, I've got a straight line, and that straight line has got a 60 degrees. Calculate the gradient of that straight line. See, how do I calculate the gradient of that straight line? I just get the tangent of 60, then I'll get the gradient of that line. So it's easy to get the gradient of the line when you're given the tan. So please make sure that that must be tan. It cannot be any other ratio, because the other ratio will use the hypotenuse. Cos uses hypotenuse, sine uses the hypotenuse. Only the tan that uses the change in y over the change in x. Right. Okay. Look at that equation now. Now, no circle has been given. We don't have any circle given. No sketch has been given, but we need to find the equation of the tangent. The picture, the sketch will give us a better picture of what we need to do. I'm going to just to draw the sketch here, but mostly in our question papers we give it with a sketch. But here, I was just lazy to draw the sketch, but let's draw it ourselves. Now I have a Cartesian plane. Now you can see here, x squared plus y squared is 12. What is this 12? It's r squared, which means my radius here will be square root of 12, which means that my radius will be square root of 12 here. That side will be negative square root of 12. There it will be square root of 12. Down there it will be negative square root of 12, because it's my radius, you see. And what is a circle? It's a set of points that are equidistant from this. So I'll just draw a circle here. Sorry about that. Right. Now I've got 0.4 and 6. So 0.4 and 6 will be somewhere square root of 4, square root of 12, 3 point something, so I'll have 3, so I'll have maybe a point somewhere, just making an example here. So there I can have maybe a point that touches that circle here at the point 4 and 6. So now what can I do here? this is just a picture of what I wanted to show you. But what can I do here to get the equation of the tangents? First of all, I must then write down the gradient of the radius. Now, what will be the gradient of the radius? So the gradient of the radius will be equals to 6/4, which is the same as, remember, how do I get the 6/4? It will be 0 minus, remember this is 0, and this is 4 and 6, for instance. So it will be 0 minus 6 divided by 0 minus 4, which gives me -6/4, which gives me 3/2 positive. Now for me to get the gradient of that line, the tangent, I need to write this one like this. So the gradient of the tangent, remember the tangent and the radius, they are they're perpendicular to each other. So the gradient of the tangent will be the same as, this is 3/2. What should be the gradient of that? So it must be -2/3. Right? So you take the 3/2 and make it 2/3, change the sign. So in this case here, I'm going to have what did I have there? So it's 3/2. The other one will be -2/3. So the equation of the line will be y minus y1 equals to m into x minus x1. Right? So I'll have y minus, my y1 will be -6. My m there, it's going to be the gradient, which is -2/3. My x minus x1, my x1 is going to be 4. So then I can just quickly multiply out -2/3x. That will be negative, will be positive 8/3. And then we're going to transpose that, I'm going to get +6. So my y value will be equals to -2/3x. And from there we'll have 8/3 plus 6, which is going to be +26/3. Which means that that line should be on the other side there. It must be on the other side, somewhere there. It cannot be like that because the gradient is negative. So yes, it's correct. So it must be somewhere on the other side because the gradient is negative. So if the gradient is negative, remember the graph is decreasing. So it must be on this side. Okay, right. If I got something like this, then I know, oh, there's something wrong because my gradient should be on the decreasing side, but not on the positive side. Okay, right. Now let's look at exam type questions. These are questions that are asked in an exam. I've taken them from past papers. So in the past papers, this is the structure of the questions that you get. Now they were just doing some warm-up questions in terms of, you know, understanding what is it that we need when we get the equation of the circle. In this case, we are having you have a story now. In the diagram, O is the center of the circle. Nice. You'll always get 0, 0 as the origin. It's the center of the circle. The straight line CD, you see that line CD here, right, is the tangent. So is the tangent, which means that it touches the circle at only one point there. And the point that is given is -4 and 3. Now D and C are the x and the y intercept of the graph. So in other words, this one is the y intercept. This one is the x intercept. Right, respectively. Of the tangent CD, of that line. It's not the y intercept of the circle, but it's the y intercept of the tangent. Now, Determine, show all your calculations the following. The first thing is the coordinates of B. Coordinates of B there. Now, this point here will be the midpoint of that line AB, because that should be equidistant from there to that. In a circle, that if that y-axis is there, it's our it's there. This line here and that line, those lines, remember that part here and that part are the same, but these ones are radii. Those ones are not radii. If you take for instance theorem number 1 in grade 11, the line from the center of the circle perpendicular to the chord, because if this line is parallel to that, this angle and that angle are equal, they're 90 degrees. So that line, if it's perpendicular to the chord, it bisects the chord. So if it bisects the chord, it means the point that is there from here to there and from there to there will be equal. So which means in this time the coordinates of B will be from here to there, it's going to be 3. So the y value will be 3, but from there to there it's 4 minus 4 units, so it must be minus 4 units. So in this case, it cannot be minus 4 units, it must be 4 units, positive 4 units. It cannot be negative. This side is negative, but on the other side, on the first quadrant, the y value should be, the x value should be positive. So the coordinates of B will be nothing else but 4 and 3. Right, because it's on the circle again, so it must make, it will make sense in terms of this and that. Okay, right. B states that the gradient of OA, I'm going to show you the easy way of doing the gradient of OA, but before, let's check this. The coordinates of this is 0, 0. We need the coordinates of A. So the gradient of OA, sorry. The gradient of OA will be equals to 0 minus 3. Remember, it's the change in y over the change in x. Right. So it's 0 minus 3 and 0 minus minus 4. So the answer that I'm going to get there will be negative 3 over 4, which is the gradient of that. The easy way to do it will be, I have a coordinate A, which is minus 4 and 3. So the gradient of OA, as long as it's from the origin, it will always be 0 minus and 0 minus. But when you practice, use that. But for now, the exam, so you can say this is the y value, this is the x value. So the gradient of this line here will be the y value divided by the x value. So the y value is 3, the x value is negative 4. That is your gradient, the same gradient as that. Okay, so if I had, for instance, the gradient of that line there, and that point was 4 and 3. So the gradient of OB will be y value is 3, the x value is 4, so those two gradients. You see? So those two gradients, which means that the gradient of that line and the gradient of that line, the other one will be positive, the other one will be negative. Now, the next question is find the equation of DC. Once they say equation, think gradients and point. The point we're talking about is this one. Remember this line, the radius is perpendicular to that. I have the gradient of OA, which is 3 over 4. So what do I need? I need the gradient of the tangent, which is the perpendicular line. So if that one is minus 3 over 4, the gradient of the other one will be 4 over 3. So we just keep and 10, change the sign. So that will be 4 over 3. But now I have got a point which is point A, which is minus 4 and 3. By the way, to get the equation of the tangent, what do I need? I need a gradient and a point. So I have the gradient and a point. So the point of y is 3. The gradient is 4 over 3. The x value there must be there. Negative, the y value should be negative into negative 4. Okay, let me write square brackets here. Then I'll have y minus 3 equals to 4 over 3 times x. This is a positive. That will be 16 over 3. Then I bring over the 3, so I'll have 4 over 3x plus 16 over 3 plus 3 from this side. So the equation will be y equals to 4 over 3x. 3 times 3 is 9. 9 and 16 will be 25. And that will be over 3. So that is the equation of a tangent. So which means, to check if I'm right, this line here has got a positive gradient. So that gradient for me is a positive gradient. So that should be fine. The y-intercept is a positive value, 25 over 3. Alright, which is 3 into 25 goes 8. So it's 8 and 1 over 3. So now, let's check what is it that the next question needs. Oh, what are the coordinates of C? Oh, C, y-intercept. What do you need to do? X must be equals to 0. The next one, what do we need? D. D is the x-intercept. The y value should be equals to 0. Which equation do I use here? I use the equation of a straight line, which is a tangent, which I got in the previous question. So my equation here is y equals to 4 over 3 x plus 25 over 3. Remember, we need the equation. We need the coordinates. So the coordinates of C will be the y-intercept, meaning that if x is 0 here, 4 over 3 times 0 is 0. 0 plus 25 over 3 is 25 over 3. So my coordinates will be 25, 0 and 25 over 3. Okay, so I can write this 8 and 1 over 3 or 25 over 3. Just leave it as a fraction, it's fine. Now, for the coordinates of D is the x-intercept, meaning that the y value should be 0. So meaning that I must work this one out. So my y value is 0, 4 over 3x plus 25 over 3. So I need to get the value of x. If I multiply throughout by 3, I'll get a 0 equals to 4x plus 25. Right? Then from there I want to make x the subject of the formula. So my x will be equals to negative 25 over 4. And I can leave my answer like that, or I can just say it's minus 6 and 1 over 4. Okay, so that is my value of x on that. So how do I write down my coordinates of D now? So my coordinates of D will be, first it will be the negative over 4 and the 0 for the y. So the y value is 0, the x value is minus 6 and 1 over 4. We're going to take a 2 minutes break and then we will be back. Okay, welcome back. Now we looking at exam type questions, and the next one is also an exam type question. In this case here, and these are questions, these questions would basically be the same. In this question here, we have the equation of we have a point A lying on the circle with center O as the origin. A line is drawn to intersect the circle at B and C. Can you see it? Intersecting this one at B and C. I'm going to add a question on this one also. Now, A is on the x-axis and AB is drawn. Determine the equation of the circle. So we've got 3 points that are on the circle, but we only have 1 point that we can use that has got values to get the equation of the circle. You see how they trick you there. With 3 points on the circle, I cannot use that, I don't know what is t. Cannot use that, I don't know what is the x value. I know the y value, but I don't know the x value. So how do I get the equation of the circle in this case? So I'll say x squared plus y squared, it equals to r squared. So for me to get the equation of the circle, I need r squared. So my x will be -5 squared. My y is going to be 12 squared equals to r squared. So I'll get 25 plus 144. And if I use my calculator correctly there, I must get 169. That's my r squared. Stop there on the r squared. If you are not asked to write down the radius. So if I'm not asked to write down the radius, my equation will be x squared plus y squared equals to 169. And I get a mark for it. Okay. Easy as that. Now the next question says, as I said, I'm going to add another question in here. The next question says the numerical value of t. In other words, we need that value of t, the numerical value of t. So I know t is on the circle. It's on the circle. Not outside, not inside, is the point on the circle. So if it's on the circle, I then substitute because it's t and 0. So I know the equation of the circle is x squared plus y squared equals to 169. That's what I know. Now I need to find t. The x value here, I'm going to replace it by t squared. The y value by 0 squared equals to 169. Can you see now I can calculate the value of t? It's easy. So I'll say t squared equals to 169. So for me to get t, I'll get the square root of t squared equals to plus minus the square root of 169. You see, in this case, I'm writing plus minus because it is not r. With r, it's positive. Now I'll get t, it's equals to plus or minus 13. I've got two values. Now I must decide. On my right-hand side of 0, this value here should be 13, positive. So I'll then say, therefore, because it's in the first quadrant, my t value will be equals to positive 13. And sometimes we lose the marks. We lose the marks because we leave our answers at t equals to plus minus square root of 13, and we leave it there. Which means that at a point, which is not asked in this case, it will be negative 13 and 0. And at C point, which was asked, it's going to be 13 and 0. Okay. All right. Now, I know that this point here is 13 and 0. Right? Now, they say determine the equation of the tangent to the circle at B. At B. Not at any other point, but at B. So the equation of the tangent is the equation of the straight line. So tangent is a straight line in the form y is equals to. Which means now I must then write down this equation in the form y is equals to. What do I need first? I need to find the radius. Because the tangent is at B. So that line is a tangent. You see the equation of the line at B. So I must first draw the tangent. And the tangent and the radius, they are perpendicular. So with this one, I must first get the gradient of the radius. So what will be the gradient of the radius? The gradient of the radius will be, remember the easy way to write it down is the y, change in y over the change in x. So that will be 12 over negative 5. All right. Please don't write it in decimal, just leave it in fractions. My 12 over negative 5, that's my gradient. So it's 0 minus 12 and 0 minus 5. So that will give you 12 over that. Then I need the gradient of the tangent. So the gradient of the tangent, which is perpendicular to the radius, I turn this one other way around, so it will be 5 over 12. The sign is negative, that sign must be positive. So I've got 5 over 12. So how do I get the equation of the tangent? So the equation y minus y1 equals to m into x minus x1. Then I substitute y minus, my point is 12, minus 5 and 12. So the y1 will be 12. The gradient that I'm going to use is the gradient of the tangent, which is 12 over 5 into x minus into minus 5. Right? So I'll have y minus 12 equals to 12 over 5 times x is 12 over 5. X, negative is positive, so I'm going to multiply 12 times 5 is 16 over 5. Or I should have written it as 12. So now I'll have y is equals to 12 over 5x, right? 12 over 5x, then plus 12. Then I can take the minus 12 there and bring it that side, it will be plus 12. So now the equation of the line there will be y is equals to 12 over 5 plus 24. Well, let's check it again. So I'll have 12 over 5, 12 over negative 5, and that will be 5 over 12, which is positive in this case. Then that will be 5 here. So my gradient there should be 5 over 12. Sorry about that. So this one will be 5 over 12, and that should be 5 over 12. So now we should have multiplied correctly. Let me do it here again. Let me do it there. So I'll have y minus 12. It's equals to 5 over 12 into x minus x1. See the mistake that I've done there. I've used 12 over 5 there instead of the gradient of the tangent. So now y minus 12, it's equal, that one should be plus 5, no? Plus 5. So it's equals to 5 over 12x plus 25 over 12. So I'm going to get y minus 12 it's equals to 5 over 12x plus 25 over 12. Then I can subtract 12, add 12 on both sides. Then I'll have y is equal to 5 over 12x. Then 12 times 12 is 144, plus that is going to be 169 all over 12. So that will be the equation. You see, easy mistakes you can do by substituting the wrong gradient into that sum. The whole thing will be incorrect. That part will be incorrect. So the correct equation will be y equals to 5 over 12x plus 169 all over 12. Right. Now, how am I going to sort of question the next question? The next question here, it's basically the same thing. In this case here, you are given a diameter. See, there's a diameter, right? It passes through the center of the circle. Now I know BC here is a tangent, so this line here will be perpendicular to that. My problem here is that I don't have T, but I've got a point here. Nice. I just need 1 point. That's all that I need. I need only 1 point for me to get the equation of the circle. But that point must be on the circle. If you look at C, it is not on the circle. Even if I knew T, I will not get the equation of the circle because that point is not on the circle. Now, in this diagram, O is the center of the circle with those points on the circumference of the circle. AOB is the diameter that's given. BC is a tangent. So once I'm told that it's a tangent, then I know. And it's a tangent at point B. Point B is on both BC, C is on both of BC and also on AC, right? On AC. So in other words, they're just telling you about that point C there. Determine the equation of the circle. How am I going to get the equation of the circle? Simple. Take a point which is on the circle. If I knew X and P, I'll take that point. But if I knew T, I will not. Reason, the point C is outside the circle, so I cannot use it. I must use points that are on the circle. So the equation x squared plus y squared equals to r squared. Take those points. X is minus 4 squared plus y is 10 squared equals to r squared. Then I'll have a 16 plus 100 equals to r squared. Then that will give us 116 equals to r squared. Then the equation of the circle must be written as x squared plus y squared equals to 116. Please, I'm repeating again, do not get the square root of 116 because that will be the radius. Only do that if I'm asked to write down the radius of that circle. So in this case, if they ask me, write down the radius of the circle, my radius will be square root of 16. Or the square root of 116. But in this case, I'm not asked to do that. Please don't do that. Okay. B says write down the coordinates of A. Now here, I don't have X value, I don't have the Y value. I'm just requested to write down the coordinates of this. As I said to say I have this line here, which forms what we call, and that line being the axis of symmetry for that. So in other words, this point that is given there will be the same as that point there, but with different signs. Okay, right, because it's a reflection of the other one. So now, write down the coordinates of A, as that one is a reflection of that, and they said write down. There's nothing to calculate in there, so I'm just writing down. So you must just know about this reflection. So if this is -4 and 10, and I come here, how am I going to write down the coordinates of A? So the coordinates of A will be the x value here. You can see it's -4. But if I go to this point here, that point there cannot be -4. That point here cannot be -4. So it should be, if this point here is a -4, equidistance from that, that should be a 4. So my point there will be 4. But if I go to P, my P value is the Y value in there. So it's a Y value there. So this one is a Y value there. So this point is a 10. But that point down there cannot be a 10. So it must be a -10. So my point A will be -4 and, 4 and -10. You just need to write down. So those points here, the reflection of the other one. So you just swap the signs. This one was a negative, this one will be a positive. This one was a positive, this one will be a negative. Okay. Even if I had a point somewhere there, I'll do the same. So end that point there. And this is also an exam type question. If I had a point, say for instance, I had a 4 and a 10. So that point on the other side will be -4 and -10. There, just change the values, x values, the signs of the two values of the x and the y. Now C says show that the gradient of BC. So the gradient of BC, I know that the gradient of that line is perpendicular to the tangent, because BC is the tangent. Look how small they've drawn the tangent, just to confuse you. But I know this is the whole line, that whole line is a tangent. Now, how do I get the gradient? How do I show? They've already given you the answer. The answer is 2/5. How do I then know the gradient of BC? So first I must get the gradient of OB. So the gradient of OB will be equals to, remember it's 0 minus 10 divided by 0 minus into -4. So the gradient of that is -10 over +4. So the gradient of OB is -5 over 2. But what do I know about the gradient of OB and the gradient of BC? When they multiply, they give us -1. So meaning that the gradient of BC will be equals to, take this upside down, then change the sign. So the gradient of BC will be 2/5. And which is what is given here. Alright. So they've given you the answer, they just want you to just show by calculations. So I can see that the gradient of that, which is the tangent here. So this is the gradient of the tangent, and that is the gradient of the radius. And I know that the gradient of the radius times the gradient of a tangent will give me -1. That you must know. Alright. Okay, D, the same answer, it says hence. So meaning that use what you got previously in the previous question. What I got on the previous question was the gradient of BC. So use what you got there to determine the equation of BC. I'm already told that BC is a tangent. Alright? And they said in the form y is equals to. So, how do I then get this in the form y is equals to? I've got the gradient, which is 2 over 5, no problem. I have the point, which is b minus 4. I prefer writing it like this, so that then I know what is the gradient, what is the point that I'm working with. So y minus, I'm just going to do it quickly, I'm not going to write down the formula now. It's y minus 10 equals to the gradient, which is 2 over 5, into x minus into minus 4. All right? So I'll get y minus 10 equals to 2 over 5x. And then 2 times that is going to be 8 over 5. So that will be 2 times that is plus 8 all over 5. Then from there, I'm now going to get y equals to 2 over 5x, because now I know the gradient of BC, 2 over 5x plus 8 over 5, then plus 10. So if I check this, it will be 2 over 5x, 10 times 5, it's 50, plus 8, it's 58 over 5. All right, that is how I can get that question. Now, I'm going to show you another method of doing it, which is quite easy. The formula is not there in the formula sheet. This formula here is there in the formula sheet, so you can get this one, but this one is not in the formula sheet, and I want you to know it and practice with it. It's an easier formula to get the equation. So what I have an x and a y. So the formula is x multiplied by x1 plus y multiplied by y1 equals to r squared. So my x1 will be minus 4, my y1 will be 10. So I take the point on that, and the r squared is my radius. So I know what my radius is. Remember, my radius was square root of 116. Radius squared will be 116. So then I'll say my x multiplied by minus 4, my y multiplied by 10 equals to 116. That's what I'll get. Then I'll say minus 4x plus 10y equals to 116. Then I have to make y the subject of the formula. So I'm using 1 point. Can you see I'm using 1 point and the radius squared? So I'll have 10y equals to 4x. I've transposed the minus 4 plus 116. So y will be equals to 4 over 10x plus 116 over 10. So my y value will be 2 into 4 goes 2 times, into 10 goes 5 times. 2 into 116 goes 58 times. Into 10 it goes 5 times. So that answer here is the same as this answer there. So I can be able to do it like that. This does not require you to get the gradient of the radius and the gradient of the other one, and then from there do that. But in this question, they want you to do it in this form. Why am I saying this? It is because they said hence. So hence means use whatever you got previously. And what you got previously was the gradient of BC. So this is just a method that I'm showing you to get the equation of the tangent. In any of the questions that we have done previously, you can use that method. But in this one specifically, this is the method that they want you to do. Hence means that use what you got. If you use this method here, you are not using what you got previously, because previously you got the gradient of BC. So here you are not using the gradient of BC, but you're using other method to get it. You're just getting the equation of the tangent, but without using what you got previously. So please, the word hence is very, very, very important. Very important. You must know how to use the word hence, meaning that use what you got in C, in this case is D, what you got in C to do the next one. So you must do that. Okay. Right. Oh, the last one there on E, we nearly missed E there. Calculate the value of T. Where is T? T is there. But if I look at T, T is on the tangent. It is not on the circle. Can you see? It's not there. So if it's on the tangent, I must use the equation of the tangent. So which is 2 over 5x plus 58 over 5. So I know that at T, my x value is 1. So my y value is T. My x value is 1 plus 58 over 5. So my T value is going to be, so it's 2 over 5 plus 58 over 5. This is quite easy, because I can see the denominators are the same. Just add the numerators and divide by that same denominator. So which will give me 60 over 5, and T will be 12. So meaning that my coordinates of T will be 1 and 12. If you look at the coordinates of that point here, it should be around, oh, it's 58 over 5, which is 11 comma something. So the 58 divided by 5 will give me 11.6. So this point is 11.6, which means that I'm correct. That one can be just above 11.6, which is 12 in this case. So please make sure that you use the correct formula. If this point was on the circle, then I'll use the equation of the circle to get the value of y. But in this case, it is not on the circle. I don't need to write it. So this one we got, the equation of the tangent we got, and these are the type of questions that we get in an exam. Now, sometimes you get a question where you have the x, these 2 points here, and you need to get the equation of that. So say for instance, I've got 4 and minus 10, right, at this point, and here I've got 1 and 12. I can get the equation of this line, and I'm given the equation of that line, and I'm given the equation of the circle. Then you use the simultaneous equation to get the equation of the other 2 points. I'm just making an example. I'm given the equation of that line here. I'm given the equation of the circle. So then they request me to get a point maybe K and point L. What I need to do is, I've got 2 equations. I can get the equation, the 2 points here by using simultaneous equation that you have done in grade 11. So that should not be a challenge here. So in other words, maybe you're given x squared plus y squared equals to 10. Then the other one is y plus 3, it's equals to y equals to 3x plus 4. You are able to get the 2 values of x by using this equation. So that you need to practice also. Go back to the simultaneous equation, then you practice that to be able to do this type of question. Lastly is the ellipse, which I want everybody to get at the end of the year. These are 3 marks. These are just 3 marks. And we're still struggling to get the 3 marks that is given to you free. Ellipse. An ellipse has a center as the origin. So we have a center as the origin, right? 2 same values for the x-intercept. So in other words, you see, it's written in the form, is written in the form, I'm going to write it here, x squared over a squared plus y squared over b squared equals to 1. So in other words, we have two same values of x, but one with a positive and the other one with a negative. So this value here must have a positive and a negative. A squared. So how do I get a? So a squared. How do I get a? So I'll get the square root of that, which is going to be plus or minus that value. Same applies to the y-intercept, the one with the positive and the other one with the negative. The longest side is the measure. So in this case, the measure is the longest side here. Is the biggest value. So in other words, we have the minor one, which is the smallest value. So the major segment and the shortest side is the minor axis of that. So this is the minor, this is the major. So that's how you can draw that. It's equidistant. So in other words, this distance and that distance are equal. This distance here and that distance must also be equal. Then you can draw a proper ellipse. Right. Let's look at the example. Sketch the graph defined by that. Simple, straightforward questions. Square root. This is, you need the x value. So what do we need? X squared equals to 49. X will be plus minus the square root of 49. As long as this side is 1. Then we have plus minus 7. You come to this graph here, you go to minus 7 and 7. You put points. That's all you do. Then you go to the y. You go y squared equals to 9. Y equals to plus minus the square root of 9. Y will be plus minus 3. So on the y, you go to plus 3. And the other one is minus 3. Then from there you just join this. Then you have your ellipse. These points must be there. See, minus 3 and minus 3 must be there. So you must write them down. In this case, I've just put a sketch where, a Cartesian plane with all the values. But if they're not there, you must write it 7, 3, minus 3, minus 7. So that then you get all through 3 marks. 1 mark will be for your y-intercept, 1 mark for the x-intercept, 1 mark for the shape. These 3 marks is quite easy and straightforward. If you look at the last one here, same thing. What is the value of x? It's plus or minus 4 because of the 16. What is the value of y? It's plus minus the square root of 35. And in this case, the square root of 35 is plus minus, I think it's 5.9. Right? You can use a calculator just to make sure that, because you cannot put the square root of 35 on the sketch. So use a decimals. So I go here, y value is 5.9, which is next to 6. You don't have to be accurate with that. So square root of 4, that one we must be accurate. The square root of 16. So the x is 4 and minus 4. The other one is 5.9. So therefore we write this, and then from there we put this, and then we put our values there. And therefore we get the full 3 marks in there. So the ellipse is so easy and straightforward. Everyone must be able to can get that. Sometimes they trick you a bit and put 4 squared here, and then maybe they put y squared over maybe square root of 35 squared equals to 1. So if they put a square here, take the 4. It's already done for you, actually. If they put square root of 35, take the square root of 35. It's already done for you. So you can be able to draw that sketch. Okay. Right. This is, as I said, this is an easy question, easy topic to do. We can get full marks on this question. Please go and practice this section. It's a grade 12 section. It's a very easy section. We can collect a lot of marks on this question. All total marks, full marks. Thank you so much.